This video is an overview of the Venus assembler. Now this is one of two assemblers. This is a simpler one, which is the one I typically use more often, but I thought I would give people an overview of simulator. It's also a simulator and a debugger maybe. Okay, so anyway, I generally never know where it is, and so I just type in Venus risk 5. Usually that finds it, and I remember it by this Venus Cavacle. I don't know what that means, but so this is it. This is an online assembler, and what I can do here is write programs on this, and I'm going to quickly write a program, and then I'm going to show you some stuff about it. Okay, so there's my program, and it's ready to go. It's ready to simulate, we'll say. So what I'm going to do is just essentially hit simulator, and then it brings up my program. Now the issue is if I make a mistake in this, it's certainly going to tell me when I make a mistake. So I'll put some weird character in there. Whatever. So there's the red underline. That's one thing. It's certainly not going to let you get by on that one. If I try to put a number in there, it's not going to let me get by on that one. So I'm not going to be able to simulate it. So it will pick out errors pretty easily on this one. And okay, so everything's good on this one. I'm going to hit simulator, and I'm in the simulation environment. So the first thing to notice is that the move instruction is actually a pseudo instruction, and so what you see here is the basic code, and this is how it gets translated. So a jump is also a pseudo instruction. It gets translated to a jump and link instruction. So this is what you wrote. This is what you get. This is what was left over after the assembler works on it. Now, the other issue on this thing is what you've got. You got the ability to dump this machine code, and all I'm going to do is hit this dump, and that machine code is now in the buffer, which I can go copy somewhere, like another text file. But more importantly, it's also down here, and we'll come and look at this in a second. Oh, let's look at it now. Okay, so this is a program in memory. And so I can go click on memory, and I hopefully can see that program. So the memory is byte oriented, and so this is the memory here. This is address 0, and so that's where the first instruction lives. So you can see it's 13055000. So this is the first instruction right here. You can see the 0A13. This is the second instruction. This works for data memory too. This is not an example that has data memory in it, but I can actually step through this program and run. I can actually run it, but honestly I've never successfully run it, and so I just step through it. Now what it's going to do is when I hit the step button, it's going to do one instruction at a time, and I'm going to go ahead and reset that. And so if you look at X, this is loading a 5 into X10, so I can actually come over here and look at X10. So X10 has 0 in it after this instruction. It has 5 in it. I'm hoping you can see that. So as I step through this thing, it's going to execute these instructions. So here's a branch instruction. Nothing amazing there, but you can see that at one point this is going to fail. And I'm going to go ahead and step it another time. Okay, so this is going to add 1 to X20. X20 has 0. I'm adding 1 to it. Now X20 has 1. This is the loop count, or this is the decrement the loop count. So this is X10 again. And once I hit this step, and that's going to decrement by 1. So the idea here is the registers in the memory, I can watch my code as I go along. And certainly I have the ability to take any of these registers here and change the values also. So once I change that value, hit return, that's going to be in that register. So this is going to help me debug stuff when and if I need to. And so I'm going to step through this. I know it's a loop. The loop counts x10, and so I'm going to step through this a couple of times pretty fast. And what you want to see is the fact that this x3 is decrementing as I step through the loop. And if I could fit that on there, you can see x20 incrementing. So at some part through this loop, now that the x10 is 0, and so it's going to come back to the branch. This is going to fail and jump down to this instruction. So the condition in here is true, so it's going to jump down here, hopefully anyway. Let's see if it does it. Okay, anyway, that's the way you work on this thing. So once again, I can, if I want to redo this, I could reset the program, restart it, clears all the registers, and I can dump it. There's my file. It's also in the buffer. So this is, like I say, this is my go-to simulator. There's actually 2 simulators. The other simulator is the RAR simulator, which I'll take a look at next. So once again, remember, this is machine code here. This is what you dump into your program, and your program is that you call it otter_memory.mem. It's just a text file. You copy this text down here, put that in your file. This is the machine code, and this is what we'll be doing all quarter to run our programs. Okay. Other settings here, you can look through this. You can change the way these values are displayed also. And I'm going to think that's about it. It's a very simple online assembler. It works great. There are some issues with it that you'll run into later, and I'll mention, but it's, for the most part, like I say, it's my go-to assembler.